And
Hi everyone. The project we'll be talking about today is targeting Expedia's niche market in travel packages via analytical and predictive modeling. And the presenters for today are G1, Zainab, Subashini, and Young, and we're all at Sweat College. So first, a little bit about the data. So this was part of the 5-college ASA Data Fest in 2017. And the data was provided by Expedia, which is a travel packages, flights, hotel deals website. And the data set had 10 million records in total, which basically had a record of all of the clicks on Expedia's websites and all of the search results that were accumulated from those. However, for our purposes and for our analysis, we only looked at searches that resulted in bookings. So we filtered our data set by the variable is booking is equal to true. After this filter, we were left with around 600,000 customer records. And for our analysis, we are looking at the response variable is package, which means that if a user booked through Expedia, whether or not they bought a package. The other explanatory variables in our analysis will be duration, which is the total number of days for a trip, days ahead, which is a variable we mutated from the number of days ahead the booking was made, and the travel date for the trip, the distance from origin, which was in miles, how far away the destination was from where the person was booking, and the party total, which is also a variable we mutated, and it included adults as well as children in a party that was traveling.
So as we mentioned, we're interested in modeling the Expedia customers that are buying travel packages. So we fit a classification decision tree on our 680,000 observations, and what the tree highlights here is of our observations, only 97% of the people, like, they don't buy the package. Only 3% of them actually buy a package. And what the tree also is highlighting here, like, the main deciding factor for purchasing a package is the duration of the trip. So if the duration is less than 2.5 days, it's 97% unlikely that a person will buy the package. And if we traverse on the right side of the tree, so like a person traveling for greater than 2.5 days, it's broken down more in terms of their preferences and origin to destination distance, their duration of travel, and the party size, and also like the number of days ahead of travel they're booking. And traversing on this right side, we identified two unique groups. And one of the groups, the group A, are customers that will buy a travel package. And group A is generally composed of customers that are traveling for more than 2.5 days, have party size greater than or equal to 6 people, and reserve at least 322 days ahead of time. And they also travel for about less than 5.5 days, and their distance to the origin to destination distance is about 2,000 miles. So that's the customers that we identified as buying a package. But then we've identified another group as group B, as those that don't buy a package. They are similar to group A in all the characteristics except for their origin to destination distance. Usually these customers travel for less than the 2,000 miles, and we've highlighted this difference on the right also. So we've just kind of zoomed into our classification tree. What we've done after that, we predicted our model on our observations. So we use the same data set of observations to train and test our model. So our classification tree says their accuracy is about 91.8%, and although this is really high, as we've said before, we've trained and tested on the same set. So our training error is 8.2%, and this may like overestimate our actual. Oh, sorry, I think this may actually overestimate our testing error. So regardless of this, we can still make a lot of insight for Expedia from the customers in Group A and Group B, and give them recommendations to convert customers in Group B to buying a travel package.
Okay. So now I'm going to talk about visualizing the data. So we mainly used D3 and R for the visualization of the data. So one of the reasons why we used D3 was that for a couple of reasons. One, that allowed for easy stylization. So if we wanted to change like the positions of certain visual representations, it was easier to do with that. If we wanted to create repeat visualization, so the same visualizations perhaps with different content, it was a really easy way to sort of process the same or similar data sets over and over again. And 3, it was really compatible with large data sets. So when we were thinking about what type of visualization we were going to make, we actually didn't know ahead of time, because we hadn't decided on the subset, but we still had to look at the visualization for the data set itself. So we looked at into D3 because it was very flexible with what we were trying to do. And the last reason was that D3 allowed for a very clean and simple visualization. It makes a lot of data easy to understand, and there are multiple libraries and resources that we could use to represent it. So you could make a bar chart, basically a collection of things from bar charts, time series data, anything you would possibly want to imagine. So really, we created this bubble chart visualization that divided our groups into 4 main groups, and this is what I would be going into detail. We divided by people from who actually bought the package over here and who didn't buy the package. Well, this does say it didn't buy the package. It's actually the group of people who were really close into buying the package, but just didn't buy the package at all. So they're kind of like these group of people who are our potential customers. And the top column of this chart basically, sorry, I meant the top row of this chart over here, basically shows the people who travel from the US to abroad, and the bottom from non-US origin, so abroad to the US. And that was our focus because a significant portion of the data set was actually based from travelers from the US. So in order to understand the data set, the bubble chart, we filter the data set by travel destination, which is sort of what I was talking about earlier. And then we recorded the number of countries that people travel to and from the most. But instead of creating this ranking, we represented this in terms of bubbles because it was just an easier way to understand the data we were dealing with. And the size basically represented the number of travelers. So the big circles are really the countries that we don't actually want to focus, because those are the countries that people travel to the most. Which means that they are basically established markets and they already have a consumer base. So Expedia doesn't really have, necessarily a potential customer base to increase there. So what we really want to focus on are really the small circles where there aren't established markets and there aren't enough people traveling to or from those countries. We also, for a bubble chart, we had the US with less opacity because it was just such a big circle that it was sort of obscuring other parts of the data, and had the most number of travelers in basically all subsets. And also the other countries were just regular opacity. And the yellow circles are basically the target countries, which is the niche market that we want to target. These are generally the small circles that we've highlighted in order to demonstrate that this is where Expedia can really target to increase their customer base and convert people who are, potential buyers into people who would actually buy their product. So what we found out was that the top countries with the most number of people traveling to the US from abroad were basically Canada, Germany, and Mexico. And you can see here in a bit more in a magnified version of the US being really big, and it's much less opacity, and this is the regular opacity. And over here we have these yellow circles like the UAE, which I'll go into detail in a future slide. We also saw that the top countries with the most number of people traveling from the US were Mexico, the Dominican Republic, and Puerto Rico. from our visualization. And it was really easy to understand that because just from the size of the circles, we were able to determine and like understand the data really quickly without having to just look at like Excel sheets and rankings of numbers over and over again. And so this is basically the group of people that didn't buy the package, and we looked at this into detail. So the countries with the small market here are these like the small circles, and you can see over here we have highlighted the UAE in yellow, and the Dominican Republic is also highlighted in yellow over here. So there doesn't exist a market there for some reason, whether those are like travel bans or sanctions, but it does have a lot of people who almost bought the packages, which are potential customers, and those were really what we delved into afterwards. However, there are some flaws with this visualization. At the time, we represented the population by the radius size to enhance sort of like the differences. While it does do that, we think that next time a better representation could be by area, just so that it doesn't necessarily skew or scale the like ratio by too much.
So another type of visualization we tried using the hotel data was more specific to the size of the party and the price bands. So if you look here, there are two bar graphs that contain information on the distribution of price bands depending on the number of people traveling for two groups, one for people who bought the packages and another group that had people who almost bought the packages. And the price bands ranged from very low, low, medium, high, and very high, and the party was from 1 to 6. And if you look at the two graphs, they generally show a similar pattern in the distribution, other than the only difference is that there are more groups of two for people who bought the packages than the people who almost bought a package. And the similar pattern is that people traveling alone are least likely to choose very high price bands. And as the party size becomes larger than 3, they prefer medium and high price bands, whereas moving away from the very low price bands. And lastly, groups under a size of 3 prefer a medium and a low range.
So finally, we have some recommendations for Expedia. So looking at this analysis, we went to Expedia.com and put in the destination as Cancun, which is a little over 3,000 miles away, for a 6-day-long trip where we're booking almost a month in advance and with a party size of 5. And we found out that this deal costed almost $1,100. And from our analysis, we found that 20,000 people fall in the rightmost category in our decision tree, as we highlighted before. And if we take the average package to be over $1,000, then that's another $23 million in revenue. So based on this and our visualizations that we talked about before, we had two main recommendations for Expedia. The first was that we should have hotel packages that are tiered according to party sizes. And the second recommendation is that we should focus on different regions for travelers who are originating from the US and for travelers who are not originating from the US, because they tend to travel to different countries with more frequency. Thank you.
Great, thank you. I believe there are a few questions. So it seems that for your project, you guys had the largest group of people, I believe 4 people. Can you tell us about how it was working as a group for a statistics research project?
Yeah, sure. So I think, a lot of us are like comp sci and SDS majors, so it was kind of easy because we had our overlaps, but we also had like our specific strengths. So I'm G1, but my, I guess, personal strength was sort of on the D3 side, so I worked a lot on like the visualization side. Some of our team members had worked a lot with R, so we really divided the work sort of based on what kind of like technical background they had and what their interests were.
Great. And then another question is, a lot of people might believe that statistics is very much about just data analysis and perhaps like number crunching, but now there is a trend for creating better methods of data visualization. And I noticed that in your presentation, you guys had a lot of different methods of conveying the trends that you found. So the question is, what would you say is the importance of data visualization?
I think the importance of data visualization is the fact that you have like a huge set of data, and perhaps data that's multidimensional that you can't parse. But really, we don't have to look at all these numbers to understand information. Information should be just, the information that you want might be like a 2-sentence thing, like, hey, this helps you increase this profit. And I think a lot of what data visualization lets you do is, one, it really summarizes your data in a compact way, and 2, it allows you to also explore the data set. Like when you looked at our machine learning tree, you were able to sort of look through the decision tree and understand the data set more and the process in which our models were created. And I think that's really the core of how data visualization can be complementary to like the statistical and mathematical aspects, and also enhance the research that you do.